Hi everyone, thank you so much for joining us for today's webinar on how to create 3D models with drones. Really quickly up front, I just want to invite you to ask your questions throughout the presentation, and we'll do our best to answer them all towards the end, and we will have a quick Q&A session towards the end as well. So with that, I want to introduce myself. I'm Cody Walgus. I'm going to be your host for today.
I'm Jackie Heshi. I'm your subject matter expert.
So we'll do a quick breakdown of the agenda today. We're going to cover how 3D modeling is currently being used in today's markets, why 3D modeling matters, what photogrammetry is and how it applies to 3D modeling, an introduction to 3D modeling and how it's done, capturing methods with UAVs for 3D modeling, and how to process imagery in software like reality capture. So to start, Jackie, can you tell us a little bit about why 3D modeling matters in today's world?
Absolutely. So the biggest field that we see is film and TV. When COVID hit, really the demand and reliance on more CGI was ever so more present. So film and TV, we also see that in video games as well. The demand for realism and one-to-one of the real world is, it's there in things like AAA games, but also in other industries like GIS, archaeological, accident recreation, simulations, and inspections. Those are also fields that we see requesting for more 3D models.
Great. Okay, so how are we seeing this shift happening today?
Yeah, some of the shift you guys probably are aware already, such as metaverse and the shift towards VR and AR. Also, video game engines such as Unreal 5 supporting more unlimited triangles is really tailored towards items like photogrammetry, where there's typically a high triangle count, but also things like view your product in 3D.
Okay, so like when you're buying shoes online, you can spin it around before popping it in the cart. Awesome. So can you tell us what is photogrammetry? What does it mean?
Yeah, photogrammetry is also known as structure from motion. It's the art and science of extracting information from photographs. The process involves taking overlapping images of an object, structure, space, and converting them into a 2D or a 3D digital model. So using overlapping images, the software uses features such as corners of structures, features on the surfaces, the surrounding base static environments. So what it does essentially is sprays a whole bunch of tie points on your image and uses those tie points to compare to the next sequence of photos. If the tie points are there and it matches to the next set of photos, then what it's going to do is going to triangulate those points together. Now, what that is essentially allows you to do is create a 3D model that gives you dimension and shape. This is also known as meshes. But the beauty with photogrammetry is also it provides you a texture layer. So this is something that a lot of other capture methods do not provide. The texture layer allows you to kind of get more context to than just dimension and shape.
Okay. So on the left here, we can see what is the mesh currently, and on the right, we have the same mesh just with the texture applied. Is that right?
Exactly, and you can see on the left there, that was purely captured by a drone. There's no lasers involved, and it was able to produce a really clean mesh. And if you look to the right there with the texture layer on, we can see a lot more context, a lot more detail on kind of the aging shape of this, this structure.
Yeah, it adds that level of realism to it.
Yep.
Okay, so now that we've covered the intro a little bit, can you tell us about the workflow for photogrammetry and 3D modeling?
Yeah, we break this workflow into 6 different steps. So that is planning, flying, importing imagery, process to HD to 3D, creating the texture, and lastly exporting as a FDX or OBJ as a 3D model. Okay,
so the first step, planning. What goes into planning a mission like this?
Yeah, planning is so important. This is probably the most time-consuming step. Your planning involves checking the weather. So really, you want to fly photogrammetry on a overcast day where there's no harsh shadows on the ground. And the reason being is that you want to neutralize the amount of shadow that's in your object, so you can be a little bit more flexible with your model later down the pipeline. So you'll be able to rotate the model later down, so you don't have any shadows already engraved in your textures.
Oh, right.
Second thing is checking the access to locations and permissions. So a lot of these cool structures and buildings are typically going to be in a protected area. You want to make sure that you ask that it's okay to scan those structures and also be aware of what hazards and safety that you may need to set up.
Right, and I guess since we're flying drones, we have to be aware of things like no-fly zones and just make sure we're following the other regulations and standards that Transport Canada has put in place.
Yep, absolutely. Safety spotter is something that we recommend as well. When you're focusing on flying and capturing these photos, sometimes you may not know, maybe you're a little too close to a tree or a building, so having that safety spotter nearby will ensure that you have a safe operation.
Okay.
And last but not least, equipment selection. Picking the right gear for the right job is important, and we can touch a little more later on these on this later.
Okay, so as part of the planning, is there anything that we have to take into consideration when we're thinking of the target that we're scanning?
Yeah, so photogrammetry can scan most things, but here are some of the ideal things that you want to kind of focus on. So static objects, so something that's not moving,
Right.
something that has very low and minimum reflectance and transparency, and something that is really high in features on the surfaces. So something like a glass, something like a white wall would be very difficult, or a very homogeneous type of pattern that's on the building would be a no-go. And lastly, 360 access to the building is really ideal. Be able to capture that entire building from all around will give you more of a realism, and again, will give you a little more flexibility later down in your pipeline workflow.
Right, so something like the target, this building in the picture, for example, this would be a difficult capture?
Yes, something like a glass building with lots of reflections with opposing environments. If you have those reflections of cars move around in the scenes, then those tie points will have a hard time trying to figure out, hey, which angle is this photo located?
That makes a lot of sense. Okay, so can you tell us a little bit about the equipment that we should be using when we're considering planning the mission?
Yeah, our go-to equipment is the DJI M300, and here's the reason why. First off, it has a 50-kilometer range. You won't necessarily use all that range when you're doing photogrammetry, but when you're typically in an urban environment, it's important to have a really strong reception when you're around the building or around an obstacle.
Right.
Second thing is having more safety features, like the M300 has 6-directional sensing and positioning. So when you're focusing on taking those photos and navigating those environments, you want to ensure that the drone is not going to accidentally hit a tree or a building. So what you can do is rely on the drone to kind of help avoid some of that.
All right, so we can still be facing our target, flying sideways, and we don't have to worry about flying in the building next to us.
Absolutely.
That's really helpful.
The third point is an easy ecosystem. Some of you here may have flown DJI already at a consumer level, maybe like a Mavic or Mavic Mini. The beauty of the DJI ecosystem is that it really translates nicely if you want to become serious and go into the enterprise world. Some of the, where the buttons are located and how to use the system, how to calibrate the system, it's all kind of familiar workflows that you can easily do on the enterprise side. Having interchangeable payloads is really nice. Maybe you want to do photogrammetry, but you also may want other payloads to do other verticals like inspections and thermals and such.
Okay.
And lastly, AirSense. AirSense is able to help you detect some nearby planes and helis. So again, safe operation is key here.
Right. Okay, so what about the payload or the sensor that we're using for this? What do we want to target today?
Yeah, so the payload that we picked is the DJI P1. The reason we chose this gimbal is because it packs a lot of punch for the money. So it comes with a mechanical global shutter. So this prevents any digital artificial warping in your photos. Again, we want just kind of a clear snapshot of your structure. It also has a 3-axis gimbal for stabilized photos and videos. So this is going to offset any of that movement that you'll be doing when you're flying the drone. It also is interchangeable with lenses between the 16, the 24, the 35, and 50. Again, a little more flexibility, be able to take some photos that might be tricky or difficult, and having that zoom will be able to kind of let you take photos further away, but retain that resolution.
Right.
It also packs a 45 megapixel full frame CMOS sensors. The more megapixel, the better. The reason being is that if, let's say, for example, using 12 megapixel, then you may need to be 4 times closer to the object to generate the same resolution. With a full frame CMOS sensor, it also helps with some of the dark spots, of the shadows in the corners of a building or such. Be able to later on in your workflow pipeline kind of enhance those areas is key, and to really remove as much noise as possible in your raw images.
Right, so having a higher quality sensor like this is going to allow you to capture a lot more quickly and with higher quality then.
Yeah.
Okay. So going into the planning stage here, what do we have to consider? How do we approach this?
Yeah, your planning is going to be, again, another step where you want to sit down and really kind of plan it well. When we plan, it's going to save you a lot of time later down the line, because once you press start and start processing, there may be some errors and they can be prevented with proper planning. So first thing we would like to do with planning is to do a wide shot. So this is going to be more like kind of a baseline shot. It really helps the software to understand what's going to be dealing with. You got the trees, you got the grass on the ground, you got a building structure. It's going to help kind of fill in the gaps where you're unable to access as well.
Okay.
The second step is going to be your closer shots. So your close-up shot allows you to ensure the photorealism of your structure. So this is going to be where you're going to be ensuring a very consistent distance from the structure.
Right.
If anybody here in the audience knows about photo mapping, it's very similar to like ground sampling distance. You want to ensure consistent distance from the object to ensure photorealism throughout and consistency as well.
Okay.
The third step would be fill in the shots. So these are kind of shots where it's difficult to access and difficult to reach. So for example, ground shots or shots that a drone can access. An example that we're going to show later on, we're going to show you that we combine both drone shots and also handheld DSLR shots.
Okay. So now we're getting into the actual flying of the mission. What do we have to be aware of on this and look out for?
Yeah, so flying, there's a lot going on. So in the video that you see here, there's actually quite a bit that's happening here. We purposely picked a day where it is an afternoon, so we have some harsh shadows on the ground. This is to kind of show you guys some of the flexibility the software is able to work through in these kind of extreme conditions. So we have the drone flying, we also have Victor capturing the ground shots, but you can see how quickly the shadow is moving on the ground. So time is at play here, especially in the later afternoons. You're going to have some, drastic moving shadows, especially when you do a multi-dimensional building with very complex structures.
Right.
While we're capturing these photos, it's important that we try to keep our ISO as low as possible to avoid noise, and also adjusting the shutter speed as we go.
Okay, so now that we've flown the mission, we're into the processing stage. What are some of the initial things that we have to consider here? Is there anything we have to do to get ready for it?
Yep. Garbage in is always garbage out. So we want to make sure that we do our due diligence and check all the photos. What I like to do is sort of kind of scroll through the photos in thumbnail view, kind of pick out some photos that I notice quickly are either blurry or are out of frame. Okay. We don't want to introduce these noise into our data set if we don't have to at the start. Right. So, delay anything that's blurry, like the one to the left, and delay anything that's just out of shot and unnecessary.
Right, because it doesn't contribute a lot to the actual project.
No.
Okay, so going a step further in processing, is there anything we have to do to the image specifically?
Yeah, so you can only do so much to try to control the external variables. Sometimes, maybe a cloud kind of moves out of the way, and now you have some shadows on the ground. In this extreme example, on the left, you can see that the totem poles are very underly exposed, and on the right, we're able to fix it in some software by playing around with the highlights, the shadows, and contrast to fix anything that's overly underexposed. It's better to adjust this or delete these photos if they're bad. You want to really make sure that all your photos is as neutral as possible, as we discussed. Be able to later on down the pipe to be able to kind of rotate the model at any angle and not have any shadows baked into your model is going to give you that flexibility.
Okay, so kind of off the bat here, I can see that it might be a little bit time consuming to individually edit all these images. Is there any way that we can kind of mitigate that?
Yeah, our go-to tool has been the Lightroom software. You're able to just drag and drop and play around with some of the settings to really kind of enhance the settings. Usually a general set of parameters will work well, but if you do know that, hey, you have a bright side and a dark side, you may want to split those photos together and adjust those separately.
Okay, and can we apply all those editing parameters to a group of photos?
Yep, it's a batch process. You go ahead and set those parameters and press run, and it'll spit out a JPEG. You probably will want to capture in RAW to have that flexibility at the start,
right,
and then just spit out as a smaller JPEG file so then the software can digest it better.
Okay. Okay, so getting a little further into the processing now, we've culled all our bad images, we've edited the ones, got them looking nice the way we want them to. What's the next step?
Yeah, so the program we use is Reality Capture, and Reality Capture has made this process really, really easy and really streamlined. I really highly recommend Reality Capture due to its lightweight size, and it's very efficient when it comes to processing. So once the images all look good, what you want to do is just simply drag and drop all those images into Reality Capture and press Align. So what this is going to do is going to create a tie point cloud.
Okay, so now we've dragged our images in, we've hit the align, we've started that process. Now, what's the next step? What are we looking for here?
Yeah, this step is critical. You want to use this as a QA and QC step. So looking at type point cloud, this is going to immediately kind of tell you some of the data gaps that you'll see in your point cloud, like the image that I have there with the rectangular box. You can see there's some data gaps there, and those are actually data gaps on the ground that were too low for the drone to capture, but we were able to fill this in later on the next day using some handheld shots.
Okay, so let's say that we weren't able to fill these in. How is that going to affect the end result here?
Yeah, if you notice that there's not a lot of points in that particular area, what's going to happen in the meshing and the texturing step is it's going to triangulate some of these points that are further out. So you may not have the same fidelity and detail like you do if you do have those points there. And obviously it will ruin kind of the photorealism of these models.
Right. Okay, so we've gotten from the point cloud now, and now we're generating a mesh. What are some of the things that we have to look for here?
Yeah, so once you've done the point cloud, you generate a mesh. So essentially what this step does is it triangulates those points into surfaces, hence the triangulation. Now this is also another step you want to kind of like zoom in on your 3D structure, kind of look around, look for anything odd meshing. Sometimes the point cloud gets confused and it'll try to mesh points that doesn't make sense. So you want to have a close look at it, and you want to clean up any steps here. If you do go ahead and go to the next step with texturing, again, you're just going to ruin the overall photorealism.
Right, so making sure we have no gaps. So it seems like before in the last step when we had the point cloud model, it seems like something of a porous surface. So now in this next step, creating the mesh, we're essentially digitally plastering over that to get one solid surface with no gaps?
Exactly. Yep.
Okay. Okay, so now that we've created our mesh, is there anything that we have to do before we get to texturizing it?
Yeah. So what Reality Capture is going to do is it's going to create the most dense mesh possible. Obviously, it wants to retain detail, but this is not going to be usable in down the workflow when you're dealing with millions and millions of triangles. We do want to downsize it a little bit to the point where we're not losing fidelity, but we're also retaining a bit of the structure. So it's a balanced play between the texture layer and the mesh layer. With the beauty with photogrammetry is that you can kind of hide some of the low poly count with the texture layer. And this is also with the assumption that your texture layer is very high quality. So your texture layer is going to be your best friend to hide some of the imperfections that you see with a low poly count.
Right, so a lower triangle count doesn't necessarily mean a bad end model. It just means that the texture is going to be doing more work to provide that detail.
Exactly.
Okay, so what do we have to do to create the texture? Is there any steps for that?
Yeah. Again, Reality Capture make this really easy. You go ahead and press the next step, which is create the texture. It'll probably take a few minutes. It is originally computationally heavy on the CPU, then goes into the GPU. Once you've created a texture layer, you can enable what's called the suite view in Reality Capture, which will enable the mesh and the texture layer. And you want to go ahead and kind of zoom in, roam around. The goal here is to kind of find imperfections in the model. You want to be critical. Again, when you give this model to somebody, they're going to look up close and try to find those imperfections. And everything looks good. You can go ahead and export it as FKX or OBJ. Now, if you do want to take a step further with further cleaning in like a software like Mesh Mixer or Blender, you can export the OBJ out, clean it up a little bit, any areas that looks kind of odd, and re-import it back into Reality Capture and reproject the texture layer.
Okay, so if you do notice imperfections at this stage, it doesn't mean you have to start over from square one. You can fix it and then bring it back in.
Exactly.
After. Good to know. Okay, well, now that we've kind of talked a little bit about the process behind capturing, can we maybe dive into some of the models that we've captured and talk a little bit more about them?
Sure.
I know right now on the screen here we've got the excavator that we recently captured. Can you tell us what equipment was used for that and kind of the approach for that one?
Yeah, the excavator model that we have is a photogrammetry model that we use with the M300 and the P1. This is kind of to show you some of the level of detail and the level of flexibility that photogrammetry is able to do. You can see that up close, we can see very high fidelity. And the goal here is to make it as photorealistic as possible. And this is kind of the beauty of photogrammetry. you can use it as an artistic kind of tool here. It's kind of a nice break with some of the qualitative scientific works that we do here at Canadrone.
Absolutely, yeah. And being a gamer myself, I mean, I've played plenty of video games where you see those small hoses and rubber lines and different pipes. They just look flat and unrealistic. So knowing that methods like this are getting better and better every day, and there's going to be more realism, is really exciting.
Yep, absolutely.
Can we take a look at the model that we captured out on that day with the totems?
Yeah, here we go. So we have the mesh, the mesh with the texture layer on for the totem poles that we captured. You can see that if I zoom in on the bear, we get some really, really great texture, right? Now, obviously, because we did it in a very challenging environment, on the front, we can see it's slightly brighter. We can see some shadows baked into the texture model. On the back, we were able to fix the model by enhancing some of the contrast, the highlights, the shadows, and kind of be able to stitch it all together. Now, how I do want to kind of emphasize on some of the imperfection that the texture layer was able to hide. So I'll go ahead and I'm going to just enable just purely the mesh. You can see the level of detail on the mesh is fairly low. We do pick up some of the grain structure on this mesh here, but when we re-enable the texture layer, we can see that the texture layer hides a lot of that. But this is great because there's one thing to use this as a artistic type of workflow, but we've seen some of our clients combine this with laser scanning, like a TLS laser scanner, to be able to get a really, really accurate and precise dimension and shape of the structure.
Okay.
And then it combines photogrammetry into this to be able to provide that context layer. So some of our clients has been using this workflow for bridge inspections. Scan the bridge and use photogrammetry to provide context, be able to see some of the rust spots, some of the chips in the paint, and so forth.
Right, so from a qualitative standpoint, photogrammetry isn't always useful, but from an aesthetic approach, we can see some of the imperfections on things, but if we want to do things like take dimensions and other measurements within the scan, then we would have to have laser scanning combined with that.
Exactly, that's right. Now, I do want to show you guys the next model here. This one is probably all the do's and don'ts, all the don'ts that you don't want to do with photogrammetry. So this is a very homogeneous building. It's very plain. There's not a lot of features going on. So this is actually a very challenging model. But having the right tool in the workflow kind of helps supplement this with the P1 with a much higher resolution camera. It can pick up some of the dust, some of the detail that you don't pick up with a lower quality camera.
Right.
So here we can see that we did combine handheld captures with our drone captures. So we can see that we got the windows. We can even see that it says here, it says Norco. And going to the stairwell, we can see that we were able to get fidelity on this side as well. And being that we used a drone and have 360 access, we are able to get the entire 3D model on here.
Amazing, yeah. So with a model like this, if we were to use terrestrial scanning, we could actually take dimensions from this and then use our photogrammetry model to apply the realistic look to it.
Exactly. Well, if your industry is, film, TV, and video games, that fidelity may not be necessarily. It would probably kind of speed up some of the workflow and the timeline of processing the data. But if you're trying to get into more engineering and surveying with this type of application, combining with a laser scanner is key.
Amazing. Okay, so I think at that point, it might be a good time to open it up to some of the questions that we may have been seeing so far. So if you guys do have questions at this point, please feel free to ask them. And if there's been any asked throughout the presentation, we'll get them sent to us here now and we can get those answered. Okay, so Jackie, Felix is asking, can you use the Matrice 30 or what about other consumer drones?
Yeah, you can absolutely use consumer drones. The main difference between consumer drone and enterprise drones is some of those safety features and autonomous features. So with the more enterprise side, it unlocks features such as facade scans, more orbit of interest, to be able to do these models autonomously. The models that we've shown you here today has been done manually, but to kind of save time, we encourage you to do and utilize some of the autonomous function on like the M300 or the M30. And with the M30, it is a great platform to do something like this as well.
Okay, so yeah, with a higher quality platform, we're going to minimize our capture time and just do things a lot more efficiently.
Yeah.
Oh, that makes sense. Okay, so Nani is asking, is 3D modeling for display and inspection purposes only, or can we get any other details like a volumetric analysis?
Yeah, so this is a great question. So when it comes to 3D modeling, under the umbrella of photogrammetry, it's broken. People kind of use the word photogrammetry everywhere, but photogrammetry can be used for qualitative purposes. We have clients who use photogrammetry under the umbrella of photo mapping, and photo mapping has been used in surveying, engineering to get volumetrics of stockpiles, to get volumetrics of like certain things.
Okay.
Now, in this particular webinar, we did mostly cover on just simply modeling for more artistic
approaches. Yeah. Okay, so Amadu's asking, is LiDAR mandatory for doing 3D photogrammetry of a facility like the building that we pictured before?
Yeah, the big difference between providing your client a point cloud like with LiDAR and a mesh product is that LiDAR is very data heavy. It's just a whole bunch of points. A lot of times your customer or your client don't know what to do with a whole bunch of points, right? It's rather than giving them a bunch of points, giving them a surface is a lot more easy for them to understand and be able to use that data later on. Now, if you're looking to get into BIM, LiDAR would probably be the best way to go with BIM modeling. Photogrammetry, you can supplement that, but again, if you combine photogrammetry and laser scanning, that would be the best together.
Okay, so JP has a comment here. He said, on the building example, I noticed issues with some of the roof edges where they are blobbish. They say they've noticed that issue with trying to create models with houses themselves. So can you speak to that a little bit and how we might be able to improve on that?
Yeah, this is, when with any type of technology, photogrammetry is not perfect. There's always going to be some limitation. And going back to some like those external variables, picking the right structure, picking the right time of the day to capture your flight is important. You can minimize those variables by controlling that. But JP, you'll be able to control some of those blobbish if you have a laser scan. So it seems like you're already doing photogrammetry. If you're well versed in that, then incorporating a TLS scan into your photogrammetry will really kind of tighten things up and prevent those blobs.
Amazing. Okay, so Tim's now asking, could we please mention some of the other Pro Tools that we referred to, like Blender?
Yeah, so you can use Blender, you can use Mesh Mixer. Really anything that supports an FDX or an OBJ file. If there are some programs that you're already using, I encourage you to quickly checking what file type you support to kind of manipulate these meshes. If you're working with polys and triangles already, likely that software is able to be able to use to kind of edit some of these meshes.
Okay. Now Rob is asking, what do we recommend for a laptop or a PC for processing this data?
Yeah, depending on your spectrum where you're at with photogrammetry, if you're either a novice, you can absolutely start with a laptop like this. This is $1,500 at $1,500 at $1,500 at like Best Buy. It's only 16 gigs RAM, an okay CPU. But if you're trying to get really serious, you do want something with high thread, high core, and high clock speed. Photogrammetry is really computationally heavy and also RAM heavy as well.
Okay, so like a good rule of thumb might be just gaming PCs.
A gaming PC is a great start. You'll be able to kind of probably ingest somewhere around between 500 to 2,000 photos before your computer kind of bugs out. It's like, hey, a little too much data here.
Too much. Okay, so RJ is asking now, is there any other processing required to remove the ground from, say, a building so it can be read for 3D printing? Also, what if you can't get to the side of a building, like in a block of buildings?
So it seems like there's two questions there. You can remove the ground, and what that essentially does is you'll just kind of have a big crater at the bottom, but in Reality Capture or some of these other software, you're able to kind of put a flat surface at the very bottom there and just print the model itself.
Okay.
So I guess kind of that ties in similar to the second question there. If you're only doing a facade or just two sides of the building, you're going to have some empty spaces in the back. If you're unable to kind of capture the back, then you're just going to have to fill it in with your own poly surfaces.
Fair enough. And then maybe grab a texture online or something that you can apply to that. Okay, so Ronald's now asking, in the intro that we have playing before our webinars, we mentioned that we do this for product shots as well. What size of products? And he gives an example like a wine bottle or much larger.
Yeah, well, these are great questions, guys. So if you're looking to do more kind of like a light box product shots, you probably don't need a drone in this particular case, but having a camera with a polarizer and really, really great lighting is key here. For an object size of like a shoe or a wine bottle, you probably would want like a turntable to kind of help the efficiency and speed. Be able to have that product turn while you snap these photos will really speed up some of the processing time and the capture time.
Right. But let's say we had something the size of a crane, for instance. It's a little hard to get into a studio, I suppose. Yeah.
So this is where controlling those external environments, so minimizing those external environments and using the drone to be able to capture all angles is how you do for these much larger items.
Amazing. Well, it looks like that's all the questions we have for now. So I guess that will bring things to an end here. Oh, we got one more just snuck in at the end. So Tim's asking, the new DJI M30 is something that I'm looking at. Can you explain the pros and cons of this drone for 3D modeling purposes and photogrammetry and LiDAR scanning purposes versus the M300 platform?
Yeah, so our main product that we really recommend is the M300. With something like the M30, it is a great product, but it sort of kind of segments you to what type of jobs you can do. With the M300, it unlocks LiDAR, unlocks photogrammetry, unlocks inspection, and all these various kind of third-party payloads like multispectral. So if you go for something like DJI M300, you're more kind of tailored towards just doing inspection and photo mapping. But if you see yourself getting serious into this, something like the M300 and its slew of various payload, is more future-proof.
Provides a lot more versatility, absolutely. Yeah. Well, I think that's all the time we have for questions right now. We do have a list of the rest that we didn't get a chance to answer, so we'll absolutely get back to those people after this session. I just want to thank everybody for taking time out of your day to join us for today's webinar. We're always trying to make our topics new and interesting and things that you guys want to actually see. So please give us your feedback. Write to us at support@candrone.com and tell us what you want to see for topics in the future. As well, you can provide all your extra questions that we didn't cover. Feel free to follow us on our social medias on LinkedIn, YouTube, Facebook, and Instagram. And thank you guys for joining, and we'll see you on the next one.